Hello everyone, welcome to Daily Ka Dose series. This is Sanjay Rathi. Today we are going to discuss important previous year questions on voltage regulator by using Zener diode. This is important for electronics student, electrical students, instrumentation branch. Okay, तो चलिए आइए start करते हैं. Practice with PYQs, journey to gate. This is a Daily Ka Dose series, guys. And that is a very important questions I am going to discuss at the end of this session. So stay tuned with me. Then guys, this is my introduction. Myself Sanjay Rathi, 24 years of teaching experience. I have qualified and selected for engineering services exam. These are my ranks and I have trained more than 1 lakh students for competitive exams. Now, this is my Telegram channel where I will upload the PDF of this session. If you have any doubts, any queries, or if you want any notification, then you can join. Link is given in description. That is Electronics by Sanjay Rathi. Now guys, that is a one question. Theory already I have discussed in Daily Ka Funda. So वहाँ जाइए, watch the theory carefully and then try to solve this question before watching the solution, guys. So first question is, a Zener diode regulator in the figure is to be designed to meet the specification IL 10 milliampere, V0 10 volt, Vin varies from 30 to 50 volt, means this is the unregulated voltage. The Zener diode has VZ 10 volt. IZK knee current is given 1 milliampere. For satisfactory operation, what is the value of R? 4 options are given. The series resistance is required here in gate 2002. That is the question in EC branch. Okay. Then how to solve this question? Then that is the diagram. Remember. Now watch this. In this question, if this is required R and IZK is given, IZ, and this is the IL and this is called I, then I is given by IZ plus IL. So what is the IZ? I minus IL. Now what is the IZ minimum? IZ minimum is given by when I is minimum and at the same time you are taking the maximum current here, IL maximum. This current should be greater than or equal to what? YZK. Why? Because Zener diode should be in what? Breakdown region for satisfactory operation of circuit. And it is possible when IZ is greater than or equal to IZK, that is called knee current. Then what is the I minimum? This is given by VI minimum minus VZ upon RS. VI minimum minus VZ, because this is in breakdown region, that's why V0 is fixed at VZ. VI minimum minus VZ upon R will give you the I minimum. And what is the IL maximum? Because it is constant, it has only single value, that is the minimum value as well as maximum. So you can put here 10. It should be greater than or equal to IZK. What is the IZK? It is given 1 milliampere. So what is the VI minimum? Input varies from 30 to 50. You can put 30 minus 10 because VZ is given as 10. R, it should be greater than or equal to 11. What is the R? Should be less than or equal to 20 by 11. You will get 1.818 kilo ohm. Or you can say R should be less than or equal to 1818 ohm. Which answer is satisfied? Will satisfy this? 1800 ohm. Answer for this question is A. So already in theory I have explained how we are going to get this formula, and this is a very important one. Directly use this formula, you can get direct answer. What is the value of series resistance? Now next question. Now this is a very important one. The Zener diode in the regulator circuit shown in the figure has a Zener voltage of 5.8 volt. What is the Zener breakdown voltage? 5.8 volt. And a Zener knee current of 0.5 milliampere. Same. The maximum load current drawn from its circuit for, this is a very important word, ensuring the proper functioning over the input voltage range between 20 and 30 volts. For proper functioning of the circuit, what is the maximum load current drawn from this circuit? When you are connecting the RL, what is the maximum load current drawn from the circuit? Means when RL is minimum. RL is minimum and V0 will remain fixed, that is the 5.8 volt. Then Always remember, to solve this type of questions, always use this formula. I is equal to what? Iz plus IL. Then I is equal to Iz plus IL. Zener diode should remain in breakdown region for satisfactory operation. That's why Iz is equal to I minus IL. So what is the Iz minimum? Iz minimum is I minimum minus IL maximum. Then what is the I minimum? And that should be greater than or equal to what? IZK, because Zener diode should remain in breakdown region for satisfactory operation. You have to satisfy this condition. Then this is I minimum. What is the I minimum? Vi minimum. This is the Vi minimum minus Vz. This is the V output upon Rs. This is the R series resistance. Minus, you have to find the IL maximum. That should be greater than or equal to IZK. Now put the value. What is the minimum value? 20. What is the Vz? 5.8. What is the R? 1 kilo ohm. That will be in milliampere. IL maximum, and that should be greater than or equal to 0.5 milliampere, because in question IZK is given as 0.5 milliampere. From this you will get IL maximum should be less than or equal to 20 minus 5.8, that is the 14.2 minus 0.5, and you will get the answer 13.7 milliampere. Answer for this question is 13.7 milliampere. This is the answer. 13.7 milliampere, guys. Okay, that will be the answer for this particular question. Now, what is the mistake here? Some students are doing mistake. They will simply, in this particular question, what is the general mistakes? I am going to explain you. They are doing, just to find the maximum load current, they are taking the Vi maximum. Just I am giving you the explanation. So when you, for maximum load current, you are taking the Vi maximum, then it will become maximum. And at the same time, Zener diode will take minimum current. So what is that? They are using this formula. I is equal to Iz plus IL. Therefore, IL is equal to will become I minus Iz. And therefore, I maximum will become I maximum minus Iz minimum. Guys, you are using this formula, but that is wrong. We have to use this formula. Always, just to satisfy, you have to use this formula and use this formula. But if suppose you are going to use this, why it is wrong? When you want to find the IL maximum, you will get the I maximum. So what is the I maximum? Vi max minus Vz upon R minus IZK. This will give you the IL maximum. So what is this? 30 minus 5.8 upon 1 kilo ohm minus 0.5, and it is what? 24.2 minus 0.5, you will get 23.7 milliampere. Is it answer? The number of solution, that is also given 23.7 milliampere. 23.7 milliampere. Now 23.7 milliampere, but that answer is wrong. Why? Suppose you are going to put the 23.7 milliampere. So what is the value of the RL? What is the value of the RL? RL, when the current is maximum, RL is minimum. So what is the RL minimum? It will become V0 upon IL maximum. IL maximum. So you are just, what is the V0? 5.8. That is the Zener diode should remain in breakdown region. 5.8 upon what? IL maximum, that is the 23.7, guys. So now when I am going to calculate this, you will get 5.8 divided by 23.7, and this is the answer, 0.2447. 0.244 kilo ohm. This is the value of the RL minimum. Now, what is the condition? Zener diode should remain in breakdown region for full range of Vi. What is the full range of Vi? 20 to 30 volt. Suppose, what is the full range of Vi? 20 to 30 volt. Suppose, what is the full range of Vi? 20 to 30 volt. Suppose, what is the full range of Vi? 20 to 30 volt. Suppose, what is the full range of Vi? 20 to 30 volt. Suppose, what is the full range of Vi? 20 to 30 volt. Suppose, what is the full range of Vi? 20 to 30 volt. Suppose, what is the full range of Vi? 20 to 30 volt. Suppose, what is the full range of Vi? 20 to 30 volt. Suppose, what is the full range of Vi? 20 to 30 volt. Suppose, what is the full range of Vi? 20 to 30 volt. Suppose, what is the full range of Vi? 20 to 30 volt. Suppose, what is the full range of Vi? 20 to 30 volt. Suppose, what is the full range of Vi? 20 to 30 volt. Suppose, what is the full range of Vi? 20 to 30 volt. Suppose, what is the full range of Vi? 20 to 30 volt. Suppose, what is the full range of Vi? 20 to if you are going to take this RL minimum, what is the value of the RS given in the question? 1 kilo ohm. If this is the RL minimum, what is the value? 0.244. And just to check the Zener diode, it should be in breakdown region. So what is the V0? V0 should be always greater than or equal to what? VZ, that is the 5.8 volt. For full range of VI, from minimum to maximum, then the Zener diode will remain in breakdown region. Now, if we are taking the minimum value, if it is in breakdown for 20 volt, then definitely it will be breakdown in 30 volt. That's why we have to check the minimum value. Now take V0 minimum. So RL minimum divided by RL minimum plus what? RS into VI minimum. Check the value. 0.244 upon 0.244 plus RS1 into what is the VI minimum? 20 volt. It should be greater than or equal to 5.8. 0.244 into 20 divided by 1.244. Guys, it is a very less value, or 3.93 only. 3.93 volt, less than what? 5.8 volt. Therefore, Zener diode is not in breakdown region. Not in breakdown region, and that's why this answer is wrong. So always remember, for full range of VI, for full range of RL, Zener diode should be in breakdown region. So in my theory, already I have explained this, why this formula is very important one. So everyone, please try to use this and try to solve all the questions with this formula. You will get always right answer. Okay. So now this is the time for assignments. So try to solve this question and give me the answer in comments box. This is the assignments. I will upload the solution on my Telegram channel, that is Electronics by Sanjay Rathi. This is a very important one, based on what? Dynamic resistance. So this is a journey to gate, how to build concept. We are taking series on what? Daily ka funda plus daily ka dose. It will continue up to what? Gate examination. That is what? Way to success, right? And this is my Telegram channel, where I will upload the PDF of this session, solution for that particular assignments. Or if you want notification, if you want to give any suggestion, then this is the channel. And then finally guys, thank you for attending the session. Like the session and subscribe our channel. Thank you.